Okay, we're here with our student Rita, and we're going to talk about fitting linear functions to data. Ready to go?
Yes.
Okay, cool. So really what this means is that you're going to have collected a whole bunch of data points when you do some sort of experiment or something like that. And those data points are represented by each one of these dots on this graph. And then what you want to do, if the graph exhibits like a linear pattern, like if the dots seem like they're kind of along a line, you know, they might, instead of being all scattered about, or if they're kind of in a circular pattern or some sort of curve or something like that, but instead like these ones, they're all kind of lined up on a line. Do you see that?
Yes.
Okay, then what you want to do is you want to say, okay, good, they're not exactly on a line, but they're kind of on a line. So let's get a line that kind of fits the middle of the data, and that's what we want to do. And then we can use that line to make predictions. Okay? So let's first ask ourselves the question, which of I've drawn 3 lines here. Only one of them is really kind of in the middle of the data. Which one is that?
Let's see. The orange line?
Yeah, the orange line is kind of in the middle here. Tell me what's wrong with the other 2 lines. How come those ones aren't really a good fit?
Well, the yellow line is more towards the left of the data. And the purple line is kind of on the outside of where the dots are.
Yeah, that's good. And the way that I would say it is this orange line seems to both have the right slope and the right y-intercept. But the purple line has the right slope, but it's too high. It has too high of a y-intercept. Does that make sense?
Oh, yeah.
And the yellow line seems to have the right y-intercept, but its slope is too steep. Okay,
right.
so what we're really looking for is the right slope and the right y-intercept. So let's go ahead and try to figure those things out. So what we want to do is after we fit the line kind of visually to the points, then we can use the Slope-Intercept Form. And the first thing that we need to find is the y-intercept. So if you look at this orange line, you can see that if you start looking at the scale here, each of the grids is 5 exactly. So 5, 10, 15, 20, 25. And the orange line hits at 20. So that's its y-intercept, okay, for the Slope-Intercept Form. Now we have to figure out the slope. That's a little bit more difficult, but we already have one point here, which is 0, 20 is 1 point. And then we can look at what's point 25. It goes up to here. That looks like it's at almost 90 right up here. So, or let's see. Let's take a look at what point we have here. Yeah, it's about at 93, it looks like. So we can take the difference in y, 93 minus 20. You can see it's about 93. And then the difference in x it goes from 0 for that first point to 25 for this point up here. So that's just 25 minus 0. And then when we calculate that out, 93 minus 20 is 73. 73 divided by 20 is about 3.7. So that's our slope. So then we can write our equation, y equals 3.7 plus 20.
Okay.
And that allows us to then have a line that's a good fit. It's called a fit line for the data. Now the question is, how does this help you? And the answer is, well, let's say this was 25 weeks of data, and we wanted to understand what would happen in week 30. Well, if all of the data points are following this pattern, we could maybe assume that week 30 would be somewhere up here, right?
Right.
So the way that we would calculate exactly where it would be as predicted by this line is to use this equation right here. And of course, the actual data point at 30 might be a little above or a little below the line, but this is our best guess at where it would be using that linear equation. Make sense?
Yeah.
Great job.